Hello everyone. So with AP Calculus, we're going to look at more derivative stuff. So this is related rates. I'm going to try and do two examples really quickly. So basically the rate that we're relating to another function is, again, the derivative. And so we're going to be looking at real world applications and other scenarios where the rate is applicable. First off, we have this example of a cone, and we're told that the diameter, this top part, is 10 units. The height is 12. I think this is like a tank, yeah, because water's going to flow into this at a rate of 10 feet cubed per minute. And the rate of change, this is going to like the derivative related rate, and all this is going to be the derivative. The rate of change of the depth at 4 feet. And so I think we're going to be finding the rate of change. What is the rate of change at that specific point? So we know the volume of a cone is 1/3 pi r squared h. And that, since we're given the diameter is 10 of that circle, the top of it, 10 equals 2 times the radius equals 5. And now we just need to find a way to relate the height to the radius. So we have the radius is 5, the height is 12. So when we do that, we get r is equal to 5h over 12, because we just multiplied this one by 5. We also know, before we go into taking the derivative of this, we know that the rate dv is changing by 10. Okay, so now we have equation again, volume equals 1/3 pi. We know r to be 5/12 h, so 5h over 12 squared. I'm going to plug that in. I'm trying to find the rate of change of depth, which is the height for it. So now we're just going to move stuff around, go down here. Sorry about that. Let me straighten out. I have 25 for 32 pi h cubed. So that's just simplifying all of that. Now we could take dv. So we're going to start doing the derivative of this now. And that whole thing. Okay, so let's go and do this. So first off, we're going to get 25, 144. And that's because of the power rule here. From this, we brought it over. So it's the power rule. So pi h squared, and then dh dt. dh dt is going to be equal to, again, we're just moving this around to get, to get to this by itself. So we're going to now multiply by the inverse, because we're going to be dividing by this thing. So that's multiplying by the inverse. We're trying to get this on its own. Remember, dv dh is here. And we want to get just this by itself. So we're going to be doing that. The inverse would be 144 25 pi h squared times our dv dt. And so now we just plug in what we know. We already know dv dt is 10, this change in rate that we were given. So we just do 10 times that 144 over 25 pi. Hey, we know that the height is going to be 4 at that point, because we were given that too. We want to find the rate of change, the depth, at 4 feet. So we were given the value for h to be squared off. Okay, so when we do this, we get 1440 over 400 pi feet per minute. That's rate of change. Could look at a second one. I'm only going to do like one part of this because it gets really long. This is part of our homework, but this example is really long. So it was talking about a ladder. Let's just draw a ladder like that, and then there's a wall. The ladder is 25 feet long, and this, the change in x, this is dx, because we're changing, it's sliding, and it's going away, the bottom part of the ladder. So that was going away at 2 feet per second. And we need to know the velocity of the top. That's again the rate of change. We need to know this, so that we need to know dy. When the base is 7 feet away. So when base or x is 7 feet away. Okay, let me just show that like that. Sorry that the camera got cut off there. So look at this. We have a triangle. Should be our first point of note. So we could do 25 squared. We need to find out these other sides. 25 squared equals x squared plus y squared. And we're gonna take our derivative of this. So it would be, starting over here, actually going to flip-flop the sides, but that's all right. 2x dx over dt plus 2y dy dt. And again, that's just the product rule. But also, we are finding changes in them, so we have to make sure we put like a d or dt on corresponding with each of the values. And again, that's going to just equal 0. Okay, so we need this dy. That's what we're looking for. And so we're going to just move some stuff around. So we need that dy. Okay, so 2y dy dt is equal to 2. Oh wait, yeah, we could make it negative. That's all right. Yeah, 2x dx dt. Okay, so what we did, we just isolated the one part that has the dy dt, which we're looking for. We do some moving around. This is after like some simplifying, moving stuff around to get just dy dt. We see that 2's are going to cancel. And we're going to divide by y as well, because we just want dy dt. We don't need that y over there. So we're going to end up getting negative x over y dx dt is equal to our dy dt, our goal of this operation. So now we know 7 feet is x, because it said when 7 feet, when the base is 7 feet away. So we know that x is 7 feet. So we have one of those values. Bam. How are we going to get our y? Well, we could go back to the Pythagorean theorem. So we know 7 squared plus y squared equals our 25 squared. If we work that out, y is going to equal 24. So now we know our x and our y, so we just plug it into this equation. So negative 7 over 24 times, we know our rate change. It's saying it's going 2 feet per second away, sliding at the bottom. Okay, so we put a 2 there, place it, we substitute it in, and then now equal dy dx. And then when we do this, we get the end result of the rate of change. This y changing is negative 7/12 feet per second. Right, so that's how you do related rates. Please look up more examples. This was again a brief overview of related rates and all these derivative things. I greatly encourage you to look up more videos and keep on learning. Have a great day. Do something nice for someone.